Hello my dear students, welcome back to the other video. This is almost the end of our discussion in the topic, and this being the last lesson, I would ask you to stay tuned and follow me and went together. So please, as usual, I would request you to follow the videos starting right away from the beginning of the topic. There's a link down here, you can access it and be able to be updated. So now let us wind up the topic by discussing the issue that we studied already in the previous video, where we are discussing issues about how best we can prove that a quadrilateral is cyclic, and then secondly, that is now related to it, showing that points of a particular quadrilateral are con-cyclic. So we discussed that time three conditions that satisfies the quadrilaterals are that is cyclic. That's if you are given any quadrilateral, you may be able to deduce that that quadrilateral is cyclic. We are looking at the three conditions of which are highlighted in my charts here. The first one, we even had the example of it. So the first we talk of if the line segment subtends equal angles at any point, at any given point. That one was done, and examples of which was also highlighted, but today we're going to focus on the remaining two. That's if the opposite angles of a quadrilateral are supplementary. A quadrilateral is not cyclic. If you realize that the opposite angles of which are supplementary, meaning to say they add up to 180 degrees, then you should be able to deduce that that quadrilateral is cyclic. And the last one, it will be this one. If the exterior angle of a quadrilateral is equal to the opposite interior angle, then that quadrilateral is cyclic, and the related points are con-cyclic. So with me here, I've got two that's examples in which you can apply any one of the two conditions. So let us look at the first example. The first example, we are given this question here, where we are told that the angle of a quadrilateral ABC D are 80, 75, 100, and 105. That is like in that order. So here we are asked to show that a quadrilateral is cyclic. Let's say is quadrilateral ABCD cyclic. And then later, once we have proved that the quadrilateral is cyclic, as I mentioned, that it means the vertices of which are con-cyclic, then we'll be able to deduce that the points that make that quadrilateral must be con-cyclic. So here we go. Now, as you are able to solve the geometric problems, as I mentioned that time, that the first thing that you should do is to produce a diagram that can guide you and where you can go. So in this case, we are going to draw the diagram first of all, representing the information on this chart here. So here it will be like a quadrilateral ABCD. It means I'll just draw a quadrilateral ABCD like this. This is just like a sketch. My angles may not be relatively be like the types of angle we have. So I may like the vertices A, B, C, D as such. So here we are told that say one of the angles is 80 degrees. So I may be able to write this one as the 80 degrees, but now it looks more like an obtuse. There's no problem. I may write this one as 80, but just take it like a sketch. And then the other one is 75. So regard this one as 75. But now, since at least the sketch should be realistic, related to the type of an angle, 75 can't be obtuse. So here I'll at least squeeze that diagram to something like this, so that the angle of which should be at least less than 90 degrees. So this to me is 75 degrees. And then we go down here, we've got 100 degrees in this case. So it means the other angle here should be 100 degrees. And lastly, we'll talk of 105, which somewhat, so this is obtuse above 90. So here, this one does not necessarily show that the angle is that's less than 90 degrees. This one shows that the angle is less than 90 degrees, but this one's obtuse above 90 degrees. So here I'll at least raise this one and try to be realistic so that this angle should be squeezed in to be acute. That is 80, like this one, and then this one should be 105 degrees. So it's more like we are indicating the angles in that order. 80 degrees, 75, 100, 105. 80 degrees, 75, 100, 105. So here it means in that order, this one is B, this is C, this is D. Light. So this is our diagram here representing this. Light. Question here. Now, the question asks us just to show that A, B, C, D is cyclic. Right, it's a cyclic quadrilateral. So, based on the conditions that we discussed, we are talking of the second one here, where we need to apply that second condition. This is the time when you can at least think of checking it. Right, so now here, the second condition tells us that if you realize that the opposite angles of that quadrilateral, they add up 180 degrees. Don't even waste your time. Just deduce that that particular quadrilateral is what? Cyclic. Now here we are. We have got angle A and angle C. They are opposite to each other. This is 80, this is 100. And the same vein, we have got angle this one, angle B, and angle D. They are also opposite to each other. So now, by the condition 2, I will try to calculate the value of the sum of the opposite angles here of this quadrilateral. So here it go like this. If I try to add angle A plus angle C, this is the same. This is just as good as say 80 degrees for angle A added with 100 degrees for angle C. So if we add 100 plus we add 80 and 100, what we get here is 180 what? Degrees. Right, so here it tells us the opposite angles are what? Supplementary. They add up to 180. The same way, if you can check these other angles, this one and this one, which are opposite to each other, you find that they are also somehow like the same as to the first one, pair of the opposite angles. So if you look at this one, we have angle B plus angle that is D is as good as having 75 degrees plus 105 degrees. And what we get here is 180 degrees. So it means both pairs of opposite angles in this quadrilateral are supplementary. Then at the end, you just deduce as to say, therefore, A, B, C, D is a cyclic quad. Right. Means there, you have proved it. Question 1. Right. That's it. Now, the moment you show that A, B, C, D is a cyclic quad, what else do you expect? It means this quadrilateral is supposed to be inscribed. That is to say, the vertices A, B, C, and D are supposed to lie on the circumference of a circle. In such a way, then we deduce that, say, therefore, since the quadrilateral is cyclic, then what we have there, A, B, C, D, are con-cyclic. That's it. So, my dear students, this is one way how you can apply the second condition in order to deduce that a quadrilateral is cyclic and the related point of which on the vertices are con-cyclic. Right. Now, let's go to example 2, which will also give us a guide on how best we can use the last condition of showing that the quadrilateral is cyclic. Right. Now, in example 2, the diagram has already been drawn, so we'll use it as such to solve the problem. Right. Right. Question 2 goes like this. In the figure, AB is given equal to AD. Angle DAB is 80 degrees. And then this angle is right angled, 90 degrees. we're also having this angle as 40 degrees. The question just asks us to show that A, B, C, D is a cyclic quadrilateral. Right, so the extension of which you already know that the moment you prove that that quadrilateral is cyclic, then what you expect from there is just a matter of the points A, B, C, D are concyclic. So it'd be like there, this line from here, C to F, is just like a produced side of DC of that particular quadrilateral if it is cyclic. Now, what we are here by condition number 3, the last one, which says if the exterior angle like that one is found to be opposite interior angle. In this case, we are looking at angle Y and angle X. The moment you realize that X is equal to Y, angle X is equal to angle Y, then definitely this must be a cyclic quadrilateral. So let's show that if angle X is equal to angle Y, in this case, our X is represented by 80, and this angle Y is here, this one represented by a gap. You can just talk of BCA. Right, so here we would like to show that this angle here, that is BCF, is equal to angle BAD. That's the thing. So that says if this is 80, this is also 80 degrees. Right, so now, in this case, the angles are not given. In the first example, the angles are given. So when now angles are not given, as I mentioned that time, it means you need to calculate the values of angles until you find the targeted angle, and then relate that that angle equal to the opposite interior angle. Right. So now let's go into business and try to do the calculations in attempts to find the value of angle BCDF. So that at the end, we compare the value of this and the one we have in this quadrilateral here, which is at A. Right, so now, this is the way we do. If we can look at triangle ADB, as I said in the previous videos, that sometimes not always direct that you can find the value of the targeted angle. You need first of all to take some steps whereby you are supposed first of all to work out the values of other angles. So those are just like a stepping stone to what you want. So like here, we need first of all to find the value of this angle here, which is this one here. Then we're going to work out the value of this angle. Once I found this one here, I'll try to add this angle here, which is 40, plus this angle here. Because I know that if this is a triangle, look at this one, triangle DBC. What I know is that the sum of the interior opposite angles when I add this and this one should be the what? Exterior angle. So the best value, or the best angle that is here going to help us to find the value of this angle is this angle here. Because we just add this one and this one, give us this one. After we're done, let's compare what value to get for this one compared to that. Right, so here we go. You write in triangle ADB, we are given that this side is equal to this side. Then definitely triangle ADB must be what? Isosceles triangle. Right. Why? Opposite sides are what? Are equal. As such, the value of this angle should be the same as what? That angle. You see that? Right. Why? Base angles of isosceles triangle are what? Are equal. Where is this coming from? We are given here. This side AD is equal to side what? BD. So, if that's the case, it means if I'm targeting at finding the value of this angle, what I have to do is just a matter of considering the issues about the sum of the angles of the triangle. That can be able to help us to work out the values of angles in that triangle such. So here it'd be like angle 80 plus this one plus that one is 180 degrees, right? So it means if I would like to work out of this angle, since I know this one is the same like that one, or say this one is equal to that one, so it means that say the remainder out of the 180, after we have deducted the 80 degrees, that one has to be what? Divided by 2, so that the remaining two angles has to share because they're equal. Remember, this plus this plus this 180 degrees. Out of 180, we'll just have this one as 80 degrees. It means the remainder has to be what? Divided. Right, so here we go. Here I'm interested at finding the value of angle ADB. Right, this angle ADB is equal to 180 degrees minus 80 degrees, then the result should be divided by 2. Reason, you write here base angles of isosceles triangle. Right. So what do you get out of that? Here we have is 100, and which has been divided by 2, and the answer is 50 degrees. That's what we get. So this angle here is 50 degrees. Right. Now, in attempt to find the value of BDC, which is a crucial angle here that will take us our way to angle BCF, you can see that here we're already given that the whole of this angle ADC is equal to what? 90 degrees. So now, if the whole of this one is 90 degrees, and part of the 90, we have found that is 50 degrees. Now, what about this remaining angle? So it'd be just like 90 minus what? 50 degrees. And you give us this angle here. Right, so this simply means as to say angle BDC, that one should be equal to 90 minus 50 degrees, which is 40 degrees as such. So it means here this angle is 40 degrees. Right, but all those angles we have just found, but they are not there as part and parcel of a question. They're just like a stepping stone to somewhere else. So now last step, having found this one as 50, this one as 40, we can now be able to calculate the value of angle BCF to be compared with what we have here. Right, so if you look at this triangle BDC, with the line produced to F, we know that this angle here is equal to the sum of the opposite interior angles in the triangle. That is 40 degrees plus another 40 degrees in this case should give us this angle here. Right, so now here you go. By this, you write here angle, you write here first because it's just like a concluding statement here. You talk of angle BCF. Angle BCF is equal to 40, different to this 40 here, plus this 40 here, this one, this plus this one, give us this. So 40 plus 40 degrees. Why? This is an exterior angle of a triangle. So you write the reason there and write exterior angles of a triangle. Right. So now, what happens? The value of which you also get what? 80 what? Degrees. Right, you can see that. This also comes in as what? 80 degrees. Or else you can use the angle sum of a triangle here to find the value of this angle here. So once you find this one, you can subtract it from 180 degrees by adjacent angles in the straight line. Then you will find this one is what? 80 degrees. Right. So in geometry, there are so many ways of killing a lot. So one of them is that you can also come with another way to more scoop of the points perfectly well. Now, here, whilst we have just found that angle as 80 degrees, then we are there now to conclude to say, since you talk of angle DAB is equal to angle BCF, which is 80 degrees, then you say, therefore, quad, look at this here now. Therefore, quadrilateral ABCD is cyclic. Right. So if they also maybe ask you to prove that the points of which A, B, C, D are concyclic, then just the moment you have just proved that this one is cyclic, then definitely you can just write and say, hence A, B, C, D are concyclic points. Right. So my dear students, this ends up the lesson of today, and ends up then the topic at large. Right. I was very happy that we have been together, really starting from the beginning, where we introduced this topic about the circle theory, right up to now. And in case maybe there are some who have just joined us along the way, please, you are still encouraged to go back right away, starting from the beginning, the videos of all the lessons, this topic. Right, go down the link here and search for them. You'll be able to watch. So where maybe you still have some problems, just do the repetition, play back the videos until we come up to the end. Where maybe there's some kind of problems, still more can be contacted at my number, which is cell 0993441801. 1 2 3 4 5 6 7 8 9 10 0 99344 here. You have to write 44181. So they can also be linking on the online. Right. So what I ask you to do, please go through everything. The exercises of which at the end, I don't usually give you that because you already have an assignment. The assignment of which is just I ask you to study right away from the beginning of the video of this topic. You follow them, go through them until at the last where we were proving that the quadrilateral is what? Cyclic. I'm very happy once again and thank you very much for listening. We end here today. Thank you.